In this application note, we focus on the ability of a unique multi-probe platform to be able to investigate and inspect silicon wafers at the nanometric and micrometric scales. Silicon photonics is a critical technology for both communications and computation, and is a growing area of interest in technology as faster communication is becoming essential in the current generation. Nanonics provides unique platforms for investigating and characterizing silicon photonic wafers. These platforms allow for the transparent injection of light, for the imaging of mode structures of silicon waveguides, even at sidewalls, and for the investigation of coupling gratings and their distribution of light correlated with topography. In this presentation, we will give an indication of how this is possible with the platforms that are provided by Nanonics. The platforms permit the integration of both scanning nanometric probes to collect light and lensed fibers also produced by Nanonics for the injection of light. As is shown in this slide, the lensed fiber can be inserted into a nanoaligner to inject light into a silicon waveguide, and the light that emanates on the opposite end of the sidewall of this silicon wafer can be imaged accurately for its mode structure, as shown in the movie that is now playing. In addition, the nano imaging probes can be used to image gratings that are on the top of the waveguide in order to investigate the coupling gratings that are often parts of these silicon wafers. And a movie of such an imaging operation is now being shown. Finally, one can see the 3D structure of the waveguide and the distribution of the evanescent field in the waveguide from the top as a result of the imaging of this waveguide using a nanometric probe capable of such surface layer imaging. Thus, with the systems that Nanonics provides, one can readily and transparently investigate quantitatively a variety of important characteristics at the nanometric scale in order to give the best indication of the functioning of such silicon photonic wafers. The movie shows a straight fiber with a nanometric point collecting light and imaging the mode structure of the silicon waveguide as shown in the image below. The full width of this mode was 0.7 microns. Only this technology has the capability of accurately imaging such waveguides. Simultaneously, it is possible to image a coupling grating that is on the surface of the waveguide using a nanometric probe with a structure that is cantilevered relative to the straight structure seen earlier. This gives both the structure of the surface and the distribution of the evanescent field that is seen in this waveguide, and a quantitative measure of the losses in the waveguide. This application note has focused on technologies that today are available that allow for detailed characterization of silicon wafers and their photonic characteristics, and are capable of being incorporated into the inspection of such wafers that are becoming so important for communication and computation.